Hello, everyone, and welcome to a new episode and special episode of the Tech Cafe podcast. My name is Ahmed Misbah, and I'll be your host for today. Please allow me to welcome today's special guest, Dr. Venkat Subramaniam, who I'll be interviewing today on various topics in software development. Thank you very much for being with us today, Venkat.
Thank you so much, Ahmed, and greetings to your listeners as well. It's a great pleasure to be here with you.
The pleasure is all ours. Dr. Venkat is an award-winning author, founder of Agile Developer Inc., a professor at the University of Houston, and the creator of the Dev2 Next conference. He has trained and mentored thousands of software developers in the US, Canada, Europe, and Asia, and is a regularly invited speaker at several international conferences. Venkat helps his clients effectively apply and succeed with sustainable agile practices on their software projects. Venkat is author and co-author of multiple technical books, including the 2007 Jolt Productivity award-winning book, Practices of an Agile Developer. You can find a list of his books at agiledeveloper.com. You can also reach out to him by email at venkats@agiledeveloper.com or on Twitter X at venkat_s. With such a wealth of experience and expertise, I'm excited to dive into some thought-provoking questions and hear your insights, Venkat. So let's start with our first question. So in 2015, you delivered a great session during Devoxx Belgium titled Core Design Principles for Software Developers. This was a very inspiring session, and I have to say it made a big difference in my career. One of the things you spoke about was the fact that programmers often confuse simple with familiar. We are excited to hear your insights today on this topic. Could you elaborate on this distinction and explain why it is important for software developers?
It's a very fundamental to really, kind of reset our thinking because we all come with different experiences. We all come up with different journeys we have been through in our lives. Even though we may be working on software projects, we have learned things in a very different way. One of my aha moments was I'm a huge fan of functional programming, but in all honesty, I came to functional programming after 20 years of programming in the imperative style. So when people said functional programming is nice and easy, I have to say it was not. It was hard for me to pick up functional programming. And the reason it was really hard is not because it was complex. It's because I was so comfortable and familiar with a different way of thinking. And so when I help programmers transition into functional programming, they look at things and say, "Oh my gosh, that looks complex." And I always ask them to pause and ask the question, are you saying it's complex, or are you saying that you are unfamiliar with it? And they would pause for a minute and say, "Well, clearly I'm unfamiliar with it, but wait a minute, if you're unfamiliar with something, then you cannot evaluate the simplicity versus complexity of things. It may be complex, or it may actually be simple, but we are really unfamiliar with it." And the nature of human mind is we tend to really put up with things that have become familiar. In fact, we may even take an extra pain doing things because they appear so natural to us only because it's very familiar to us, or we've been doing it so many times that it has become a muscle memory for us. We don't even think about it when we do it. On the other hand, if we were to take something that's very different from what we do, we may find a bit apprehensive or a lot apprehensive, depending on how different it is. But once we transition into it, then we get to evaluate whether it's really simple or maybe it actually is complex. So when discussing with developers oftentimes, and especially for my own internal mind, I always ask the question, am I judging this because this is familiar to me or unfamiliar to me? Or am I judging this because I'm familiar and now I can focus on the real qualities of what I'm evaluating? So I think it's really useful in conversation to reset our thinking and ask the question, are we biased by our familiarity or the lack thereof in situations, or are we really focusing on the essence of what is being evaluated?
Thank you very much for that. I think the distinction between the two concepts is now very clear. Let's move to our second question. So I've heard many discussions about the difference between complex and complicated. I would love to hear your perspective on this distinction and why you believe software development is inherently a complex problem.
Yeah, well, I would argue we as humans cannot shy away from doing hard things because that's our job. I get hired to solve hard problems. You get hired to solve hard problems. If we are going to be scared of hard problems, sorry, we're in the wrong field. There are two kinds of complexities that we often talk about. One is called the incidental complexity, and the other is the accidental complexity. The incidental complexity is the nature of the domain and the problem that we are dealing with. You may be dealing with insurance. Well, you may be probably one of the most complicated things, at least here in the US for us, is the tax-related, things we need to deal with. Humans have created maybe nothing more complex than tax laws, if you will. Imagine having to deal with not only tax, but also changes to the tax laws continuously. Banking has complexities, medicine has complexity. So these are all inherent complexities. Accidental complexity really comes from the solution that we choose. And if we implement one solution versus a different solution, they may have varying degree of complexity versus simplicity. You may argue, oh, if you use this solution, it becomes a simpler way to solve the problem than using this other solution. And our capability as programmers is to head on address the incidental complexity and actively reduce the accidental complexity. But having said that, we could deal with these complexities back and forth, but I begin to realize that the complexity is a bit of a negative word, and we don't want things to be complex. We want things to be simple. However, there are certain things that are inherently complex. This is when I want to use the word complicated. So a tax law is complicated, but I don't want to take what is complicated and introduce complexity into it. So, in other words, the nature of what we deal with is complicated, but our genuine ability and skill should be to deal with what's complicated, but without introducing complexity into what is already complicated. So I don't think we want to shy away from complicated things because that's our job. We get hired to solve hard problems, or I could say complicated problems. But our real strength and capability is to solve complicated problems, but without dragging complexities into it. So my recommendation is fight for that simplicity, but fight for the simplicity to solve complicated problems.
Thank you very much for that answer. I think, at least to me, the distinction between the two concepts is, again, very clear. Let's move to our third question, and this is about Java. So Java has evolved significantly over the years with new features and enhancements. Which recent features of Java do you believe has had the most significant impact on how we write code today, and why?
That's a hard question to answer. And the reason it's hard is Java has evolved so much in the recent years that there is such a wealth of capabilities. And in a way, I would argue I'll give you two-part answers to this question. One is a little bit, older by today's day. 10 years ago, I was very truly excited about the functional programming capabilities in Java. I think that fundamentally changed the way we write code. Before that time, we could write object-oriented and imperative-style code in Java, but starting Java 8, we can not only write object-oriented and imperative style, but also write functional style of coding. So I think that probably is one of the most significant changes to Java at the time. But moving forward from Java 8 to maybe current versions of Java, even Java 22 or about to be released Java 23, I would say rather than answering the question as to which feature, I would argue one of the beautiful things about Java is not just the features themselves, but the interplay of the features. That's what excites me the most. You can have 20 features, that's great. But what really becomes exciting is when the features are not pointing in different directions, but there's a synergy in the features coming together. So for example, if I were to bring three features and the synergy of their through their interplay, I would say pattern matching along with records and sealed classes really are a nice interplay of features. You can use pattern matching to reduce the verbosity in code and make it expressive. I program in about 15 different languages. What I mean by that is I'm not good in any one of them, but I love programming languages. And if you ask me, over the years, honestly, when I program in different languages, what is one of the things I look for in the languages? Honestly, it has been pattern matching. I fell in love with pattern matching maybe 15, 20 years ago when I was working with Erlang. And Erlang has a beautiful pattern matching syntax. You can see that also in languages like, to a certain extent in language like Ruby and Scala and Kotlin. So when I saw Java is introducing pattern matching, I was truly excited. But not only does Java have pattern matching, but if you have sealed classes, it enables completeness much more easily in pattern matching. With records, pattern matching works really well with the concept of destructuring, which is yet another very powerful feature. So to me, that interplay of those features are really exciting. So, and your question was about writing code. And so with the focus of writing code, I would say starting with functional programming capability into this interplay of pattern matching with sealed classes with records would be what I would label. But if I remove that writing code part just for a minute, if I take that liberty to do so and talk about what's the most significant impact today, I would have a very different answer. Not as much about writing code, but as much about deploying code and the impact on production. And for that, my answer would be hands down the concept of virtual threads. And the reason I would say concept of virtual threads is virtual threads have an impact on the scalability of your servers. In a way, somebody was asking me a while ago, how do you compare reactive programming to virtual threads? And my answer is reactive programming helps to scale your services. Virtual thread helps you to scale your servers. And that is one of the biggest powers is your company, which is already deploying Java applications, all of a sudden, with very minimum change in code, can benefit from much higher scalability when your code is using asynchronous communication. So to me, that is an enormous impact with very little code you need to be changing to reap that benefit for scalability. So it's a hard question because I feel like a kid in a candy store. If you take a kid into the store and say, pick one candy, well, you destroyed the child. That's how I feel about it. Is there so many wonderful things to pick from? It's really hard to say, I'll just walk away with that one thing. I want them all. And the beauty is the synergy and the interplay between those features as well, in my opinion.
Yeah, that's a great answer, Venkat. And the nice thing about it is that while I was expecting you to tell me a very specific feature, you've actually given us more than that. So it's the interplay and synergy between the features and not just the features. So you're right about that. And I think you've taught us something today about how we can evaluate the different features that a programming language launches. So it's not just the features, it's the interplay and the synergy. Thank you a lot, Venkat, for that. So I've noticed that you've mentioned functional programming in almost all of the previous answers. And I had a question prepared for you on that topic. So you've delivered multiple talks on revisiting design patterns in modern Java, specifically by refactoring to functional style implementations. As functional programming has been gaining traction in recent years, what are some of the key advantages of functional programming that you believe every developer should understand? Additionally, how can these principles be effectively integrated into an object-oriented language like Java?
Oh, beautiful, beautiful question. Lovely. So let's take the first part of the question to begin with. One of the things I want to really emphasize is I don't want to become really biased or fanatic about a certain concepts. There are people who would say it's functional way or the highway. That's the only way to do things. I don't believe that. And I truly believe that whether it's imperative or functional, these are tools on our hand. I don't want to walk into a garage and say, I've got a screwdriver and that's the only thing I'm going to use. On the contrary, when I walk into the garage, my question is, what problem am I trying to solve? And then ask the question, do I want to use a screwdriver or a hammer or a chisel or, what is, sometimes an Allen wrench is the right thing to use. So the key here is that functional programming can be a right choice for a certain problems at hand, but may not be the right choice for other problems. But looking at the benefit itself, I would say that the very first and foremost benefit is that functional programming is declarative in nature. And declarative programming reduces the accidental complexity. Let me give you a trivial example to just kind of latch onto that idea. You give me a bunch of names and you are asking me to see if a particular name is in that particular list. I can start an index, a loop I equal to 0, I less than the collection dot length. My gosh, that's too much work. Let's simplify this. Oh, for, you can use the for each construct, a variable name, colon, the collection of names. But then inside that, you check if it's equal. And if it is, you set a flag and you have to break out of the loop. That is imperative style of programming. Imperative style is where you have to give instructions for every level, every step. This is like having a little toddler at home, and you got to tell the toddler, please hold the glass with both your hands, watch where you're going, and please don't step on that cat as you are walking. And the first day when you're with the toddler, it's a lot of fun. The second day and the third day, you're like, my gosh, this is going to go on for the next 18 years of my life taking care of this kid, right? That's the way we feel as parents, is that you got to repeat the same things over and over. That is imperative style. Declarative style, given the collection of names, dot contains the name you're looking for. You're done. The contains function absorbs all the details of what you want to do. You don't worry about how the contains works. You just call the contains function. That is declarative style. This is like telling a responsible person in the house, could you please get me a glass of water? You don't have to tell them how to get a glass of water. So you would rely on telling what you want, not on how to actually do it. And because functional style is declarative in nature, it reduces that accidental complexity a lot for you in your development. So that is one of the biggest benefits you get from this idea of functional programming. But taking that idea a little further, the code begins to read like the problem statement. That is one of the biggest benefits of it. When you're reading through an imperative style code, we often talk about the spaghetti code. And even if it's not spaghetti code, it tends to evolve towards being spaghetti. There's entropy that is pulling the code in the direction of that accidental complexity. On the other hand, if you will, the functional style code flows naturally, where you're saying, given this particular data, get me all these data, drop the remaining data out, apply this transformation, only get these many data, and collect them into this resulting collection. The code begins to read like the problem statement. So one of the biggest benefits you're going to gain in this case is that ability for you to express your ideas in a way it reduces the accidental complexity. But take that one notch up from there. Because of the nature of the functional style code, it blends itself naturally to parallelize it. So if you really think about it, you can twiddle with things and make it incrementally better in performance, but where it's really necessary, you can get leaps and bounds of performance by running the code in parallel. If I give you an imperative style code and I tell you parallelize it, your useful response is to laugh, because the only options you have is to laugh or cry, because an imperative style code is incredibly difficult to parallelize. A functional style code is almost trivial to parallelize it, and that is another big advantage you are getting. So the code is less complex. It has less accidental complexity. It's easier to understand, easier to read, easier to maintain, and it's easier to parallelize as well. So those become the fundamental benefits. Now, leaping into the next part of your question, which is another thing I really truly, and I'm glad you asked that question, because there are a lot of people who unfortunately pitch the functional style of programming against object-oriented style of programming. Brian Getz, who is the chief architect of Java, has a fantastic talk. If listeners Google for it, they'll find it. His talk, if I'm not confusing the title, says something like, OO versus FP, choose two, he says. So that's a beautiful way to think about it. So his argument is, you don't want to pitch functional programming against object-oriented programming. My opinion is, if you look at most languages in the world, let's list a few just for the sake of fun, starting with JavaScript to Python to Ruby to Groovy, Kotlin, Scala, Java, C Sharp, and keep going. Every one of these languages are hybrid, object-oriented, and functional programming languages. So in other words, these languages are not purely object-oriented. These are not purely functional programming. They give you the capability to do both at the same time. And again, this is where our skill to really understand why we are solving problems and what problems are we trying to solve. So the enemy in this is not object-oriented programming. People bash OOP and say, oh my gosh, it's terrible. Well, I have a different opinion. Object-oriented programming is fantastic. It gives us the ability to perform abstraction and encapsulation combined with polymorphism. That is incredibly powerful. Our enemy is not OOP. Our enemy is the accidental complexity that comes from the imperative style of programming. So what you want to attack is that accidental complexity, not your object-oriented benefits that it brings to the table. So if you think of a functional pipeline, your data flows through the functional pipeline in a functional style of programming. This is very similar to the Unix programming model, where you use the vertical pipes and you say, here's a source of data. I can pipe it to a grep. Grep is like your filter. I can pipe that to a awk or a set command, which is like your map function. So this idea of transformation of data is the essence of this functional pipeline. But the beauty is, once I draw a functional pipeline, the data that flows through can be primitive data or can be objects themselves. This is where the nice interplay between OOP that flows through the functional pipeline comes in. If I can use a crude analogy here, let's say you ask me to build a house. Well, I'm going to use bricks to build a house. Great. Bricks are your objects. How do I glue the bricks together? I can put clay together and mix them together. Think of the clay as the imperative style, maybe a bit brittle, maybe not long lasting. And house built on clay is going to only stay for so long. Or I can use cement to glue the bricks together. Think of the cement as your functional pipeline, your functional programming. So your objects are your building blocks, but how you glue them together could be imperative clay or a functional cement. So that may be a nice way to bring them together as well. And that's the kind of the view that I carry with me, is how you can bring OOP and functional together and benefit with the best of both worlds mixed together, rather than throwing what actually works really well and be biased towards taking one or the other.
Yeah, I liked a lot the part where you said that we have to start moving away from object-oriented versus functional to object-oriented and functional. So yeah, this makes a lot of sense. Let's move to our next question, and this one is about virtual threads. So what is the impact of the new virtual threads in Java on the use of reactive programming for backend systems?
Lovely. So you probably have heard people say, "Oh my gosh, with virtual threads, reactive programming is dead." I beg to differ. I do not agree with that statement. But in order to clarify that, let's step back for a minute and talk about what does reactive programming mean to us. And to me, reactive programming means two separate things in my mind. The first one about reactive programming is it allows me to perform asynchronous calls. So this is one of the reasons why, as an example, in Spring, we have flux and mono. So when you call a function, when you get back a flux or a mono, you're able to get the data back asynchronously rather than waiting on the data to be received right now. So you make a call to a function, immediately you got a flux or a mono, but you haven't gotten the data yet. And then when the data becomes available, that gets pushed down that pipeline, and you get the data either through the mono, if it's a single piece of data, or a series of data through a flux, if it were a flux. So on one hand, you got the asynchronous part in reactive programming. On the other aspect, I like reactive programming for its ability to provide a stream of data, but more so its ability to handle back pressure. There are different back pressure strategies that you can implement. If the data flow is really rapid, but I'm not able to handle them at a faster rate, you can implement a strategy that makes sense to your application. If I am an application that's processing cars that are running through a toll booth, I want to be able to charge every one of them because that's got an impact on my business. In such case, I simply want to buffer the data as they come in and be able to process them. Now, in this case, I have a peak hour 8 a.m. to 10 a.m. and a kind of a not so peak hour from 10 to 2 in the afternoon. So I can back pressure those into a buffer. When the load is less, I can take the time to process the ones I've buffered. That makes sense. On the other hand, if I'm in a system where I just need to monitor where a particular person is as they are driving through town, well, it doesn't matter where they have been. It matters where they are right now. So I could be getting a stream of data, but I'm busy processing something. I can discard some of the data and only look at the latest information available, and a combination of few other strategies we can implement. So now that we talked about the two key angles in which you can look at reactive programming, I would say if your primary goal for using reactive programming was only for the asynchronous aspect, then I would argue maybe you don't need reactive programming anymore on the back end. You can instead use virtual threads because virtual thread gives you that asynchrony in a very elegant manner. You don't need to endure the pain of using reactive streams in order to gain that asynchronous behavior of your code. However, what virtual threads does not address at all is the back pressure aspects of things. The concept of virtual threads and back pressure are entirely orthogonal to each other. There is no relationship between the two. So if I want back pressure, reactive programming can still be an option to benefit from back pressure. And I think this is where we need to really, ask the question, what is my intent of using a technology? If the intent were what is replaced by this alternative, maybe in a better way, then maybe I don't need to use this anymore. But if the intent was something different, and if it doesn't address that, then there is a place for both of them at the same time. So the answer to your question is, as the team, what they are using reactive programming for. And if their use of reactive programming was purely for asynchronous, it's better that they drop it down and move towards virtual threads. If the intent for them was to use it for back pressure, then I think they should still continue to use it. If their intent was to use it for both, I would encourage them to use virtual threads for asynchrony moving forward, because that's more simpler, and use the buffering and the back pressure through reactive programming. Then they can benefit from both technologies, but for two different purposes. That would be my view of when that would make sense to use which one in this context.
Yeah, that's perfect. Thank you a lot, Venkat. So let's talk a little about agile practices and technical excellence. So you've worked extensively with agile practices across various organizations and cultures. What are some of the most common misconceptions, pitfalls, or anti-patterns you've encountered in agile implementations? And how do you address them when training teams and organizations?
This is really a sad situation we are in, because a lot of practices that a lot of companies do are quite contrary to the intent of the people who wrote the Agile Manifesto. And we have gone to, so let me step back and say this. This is the reality of us as humans. We humans love rituals. The reason we love rituals is rituals give us relief from reality. We can practice a few rituals and take the burden off of our shoulders, worrying about the realities of what we need to face. So we often are eager to get prescriptions. And we say, tell me what are the do's and don'ts. Tell me what are the best practices. Tell me what I should do. My recommendation is we need to be agile about being agile. So what are some of the problems we often see? The problem often we see is organizations are keen on following a process or a methodology. They want guidance. I'm not blaming them for needing guidance. Every one of us need guidance. But the problem is, if we take the guidance as a pill and we start following that guidance or guidelines, then we end up actually getting trapped into a ritual rather than asking, does this make sense for my situation? Maybe I should do something different. Maybe I should do more of something versus less of something. And also, what I noticed predominantly is, if you go back to before the time of Agile Manifesto, we had extreme programming. Extreme programming was rather very technical in its nature. We talk about refactoring, we talk about code reviews, we talk about continuous integration. A lot of those are technical practices. Then on the other hand, we got eventually what we call, look at as a Scrum, is things that are oriented towards process management, estimation, planning, release planning. But as Agile become more and more adopted, what happened was organizations started embracing the process, but somewhat left out and forgot about the technical practices that are the underpinning. Unfortunately, though, if you focus on providing the agility at the process level, but if you don't have the technical underpinning to make that happen, then you're not able to sustain your agile efforts. And then we turn around and complain that agile doesn't work. Well, it's not about agile working or not. You don't want to do agile. You don't do agile. You want to be agile. So there's no, we are doing agile is a misnomer. You don't do agile. You need to be agile. But how do you be agile? Well, to me, agile development is feedback driven development. And that is exactly what agile development is. It's a feedback driven development. When I'm driving across town, what do? I look at my map. My map says you're going to get there at 5 p.m. Great. My meeting is at 5:30. I'll be 30 minutes ahead. Awesome. Well, as I'm driving, my map suddenly, gives me a little alert and says there's been an accident on the road and there's a major delay of 20 minutes. Now you will arrive at 5:20 p.m. Well, that's a useful feedback. If the person I'm going to meet is important, well, if it's not important, I should not be going to this meeting. But if it's important, I need to call them and say, hey, I'm driving and there's a traffic jam. I'm going to be there 10 minutes ahead as of now. I just want to give you a heads up. I might run a little late. Well, this is called responsibility. So to use that feedback loop is extremely important. So when I train teams, I work with the teams to ask the question, how do you make use of the feedback loops? One of the most important things about agile development is what's called adaptive planning. Ahmed, I'll tell you one of the worst tweets I ever made. And this tweet drew more retweets than I ever imagined. And my tweet simply said, I haven't asked her out yet, but I've set the wedding date already. This is how projects are managed. If you really think about it, we set the deadline before even knowing what are the complexities involved in what we are building. So one of the most important things I train teams is how do you make use of adaptive planning? It is not about what you planned, but how do you change your plan so you can still succeed within the goals you set, but the goals have to be reasonable and practical in what you set. And then to come back and say, to really provide that agility, the engine of agility, how do you keep that engine of agility moving forward? And what are the oil and the lubricants you can provide for it to smoothly run? That's your technical underpinning. So I work with the technical people to bring in the code quality and the code reviews and the automated testing aspects of things, all the way from continuous integration to continuous delivery. I do continuous delivery on a daily basis. I click a button, and the next thing you know, the application is in production. I don't have to waste my time. I'm able to produce more code faster because I've implemented various technical practices along the way. Did the practices take time? Oh my gosh, of course it did. So one of the key things I often tell people is you have to slow down in order to gain speed. If you're not willing to slow down, you're going to end up in the ditch when when the road is curving. So one of the things about agile development is not speed. It's about sustainable speed. What that means is there are times when you ask your team to slow down just a bit so that they can now accelerate and gain that speed. I once tweeted, I do automated testing not because I have a lot of time. It is because I don't. And that is the reality. I don't have a lot of time. I'm always split across so many different things around the world. And so my time is limited. And the time I spend on writing code, I want to make sure it's very, very productive. And one way I can do that is to ensure quality and have automated tests. It saves me time every time I touch the code later on. So that is the maturity of the team to detach from process and rituals and ask the question, what are my goals and what are the things I can do in order to get to those goals? This goes back to what we talked about in functional programming. Don't take functional programming and say, this is the only hammer I like. I'm going to do functional programming. I don't care what you're solving. Same thing in agility. Don't take a process and say, that's my process. That's the hammer I'm going to use. Instead, work your way backwards from the goal. This is what I want to achieve. In order for me to achieve those goals, what are the things my team need to do? These may be difficult things for us to do, but by doing difficult things, we become more mature, skillful, capable, and gain the confidence to deliver those results. So that is what I work with teams, is to educate them and work with them on doing the hard things to attain that level of agility than doing the easy things. I give a term, I call it agile by convenience, as a lot of teams do. Agile by convenience. We want to do agile development. Let's pick things. Oh, that's hard. Don't do that. That's hard. Don't do that. Oh, that one we can do. That's easy. No, don't do agile by convenience. Instead, focus on how to get the results and fine tune the things you do in order to be agile and get the results you want.
So many takeaways in this answer. We have been reading for so many years now articles titled "Waterfall is dead, long live the new waterfall, long live waterfall 2.0." So basically, people are starting to think that Agile is basically the new waterfall. I think one of the key takeaways in your answer was that we need to be agile about being agile. I think I'm going to turn this into a quote because it really is. We really need to be agile about being agile. Otherwise, as everyone can see, it's just another waterfall. Another key takeaway was that we don't do automated testing, which is one of Agile's technical excellence or technical practices, I'm sorry. Not because you have the time, it's because you don't. And I think this is a great pitch for test-first approaches and automated testing. Now, speaking about test-first approaches, I want to ask a question related to one of my favorite Agile practices, and that is TDD. So in 2015, you delivered a wonderful session titled Pragmatics of TDD to Evolve Design, where you discussed some of the challenges with TDD and offered practical solutions for leveraging it effectively. Many in the software engineering community view TDD merely as a testing technique or strategy. Can you explain why this perception is misleading and elaborate on why TDD is fundamentally a development and design approach? Additionally, how can teams use TDD to deliver high-quality designs?
I consider Ken Beck as, if I may, the father of test-driven development. That's just my personal opinion. Is he really influenced TDD in terms of the practice? One of the words that Ken Beck uses here, if I may leverage that, is he said, test-driven development is an act of design more than an act of verification. I think that's a very fundamental message we can learn from. So to me, here's the problem. If you were to implement a piece of code and the code has been written, and without judging on the quality of the code, I come in now and say, I want to write some test cases around this code. There is a severe limitation on how much test you can write for that particular code, because the code has been implemented in a certain way. It's not going to allow you to reach in and be able to do the testing the way you want to. So oftentimes what happens is when we write test after writing code, we write a little bit of test here and there, and we kind of move on saying that's all we can do. On the other hand, if you do a test first development, there are two separate benefits available for you. The first benefit is the structure of the code can be influenced by the test you are writing. That's one of the biggest benefits. So I often say, people often tell me, we do test-driven development. Do you want to look at our test? And I say with respect, I don't need to look at your test. I can look at your code. I can tell you whether you do TDD or not. So here's a way to think about it, right? If I tell you, do you want to look at my gym? I've got heavy weights there, and I can lift 200 pounds of weight every day. You can tell me, Venkat, I'm sorry, I don't need to look at your gym to tell you whether you lift heavy weights. Just show me your arms. I can tell you whether you lift heavy weights. I don't, as you can see. So you don't need to look at my gym to tell me my exercise habits. You just need to look at me. I can look at the code and tell you whether it's test-driven or not, because the shape of the code is different when it's done TDD or not. If I was lifting 200 pounds a day, you're going to see much bigger arms on me than you can see right now. The point really is test-driven development, test-first development influences the structure of your code, meaning it influences the design of your code. Not only that, to me, test-driven development, this was my realization. Test-driven development for me is not test code, test code, test code, test code. No, it's not a mechanical process. It is write a test, stare at it, ask the question, does this test tell me that the code I've not written yet, but I'm about to write, is actually the code I want to write? I want to put myself in the shoes of the person using this code. How does it feel? Does it feel like this is a code you want to interact with? Or does it look heavyweight? Does it look cumbersome? Does it look like you got to set up a lot of things before you can call this function? Maybe I shouldn't be writing this test. Let me modify it. Let me modify it. So I write a test. I stare at it. I debate about it. I rethink about the design of the code that I've still written, and then get to the point where I feel like, okay, this seems like a reasonable code to write. Now let's write it. One of the practices I follow in this is, I want to write a series of tests. So I'm going to write, let's say, 5 tests as an example. But the very first test I'm writing, this is not telling me what to implement in that function. The next test I'm writing is bringing a little bit of an implementation. The third test and the fourth test and the fifth test are bringing more implementations in. So in other words, I let my test design my code from the outside in. So metaphorically speaking, I say, my first few tests help me to tease out the skin of the function. And the next few tests I'm writing help me to tease out the guts of the function. So literally to me, the tests are influencing how the code evolves. I often tell that when I walk down the test cases, it is telling me a story of how the code actually evolved from outside in. The first test is saying, here's the name of your function. Here are the parameters I'm going to send to it. Here's the return type. The next test says, bring in a little bit of logic. The next test after that says, put in a little bit more logic into it. And then I'm growing this code one step at a time. And as I see the code grow, I take the time to refactor it, apply good design principles, single responsibility principle, single level of abstraction principle, and so on, or dry principle, and I refactor the code. So to me, the whole game of writing test cases is my ability to design the code. Added to that is the benefit of really being able to get the regression benefit. I'm modifying the code and I get a real quick feedback. If the new design, if the new change, if fixing a bug is causing some code that exists to break. So we have both the benefits of TDD, the design benefit and the regression benefit. If I write the test after, I don't have the design benefit. But not only that, I have less of the regression benefit because my tests are not effective when I write it on existing code. So there's only so much of regression I can build into it. So if you do test first development, you get 100% benefit. If you do test after development, maybe you get 25% benefit because 50% dropped out because you're not influenced by the design. And the other 50%, maybe 25% got dropped out because you can't reach in and write the test properly, and your regression benefit is less as well. This really is a skill. This really is something that takes practice. This doesn't require extraordinary behavior in teams. Discipline, unfortunately, is in short supply. And as they say, if you are doing something as a professional, the discipline and integrity is within. We can all give excuses. We can tell, only if my boss allowed me to do this, only if my management allowed me to do this. But to some extent, we as developers, A, have to take responsibility, and B, have to influence the behavior of others around us so we can do the right things. I always ask people, imagine the doctor who is looking at your kid's health is taking shortcuts because they have to respond to a management pressure. Is that the type of doctor you want to go to? Doctors are professional. So are we as programmers. And so there is responsibilities, ethics, and professionalism that we need to think about as well for what we do. And that's our line of thinking we should engage in, I think.
Thank you very much for that, Venkat. I like the part where you said I can look at code and tell if it was written using TDD or not. It reminded me of Michael Feather's definition of what legacy code is. It is simply code without tests. And what you've just said right now is very similar to his definition. I also remember Martin Fowler saying that one of the ways of ruining TDD is by skipping refactoring, which is basically the phase where you do design and where you improve design as well. So yeah, when you don't do TDD, you can simply look at the code and tell if it was not written using test first approaches. So speaking of legacy code, that is the topic of our next question. So legacy code is a challenge that many developers encounter throughout their career. Given its complexities and the common complaints surrounding it, what is your secret sauce for working effectively with legacy code? And can you share with us some strategies or recommended practices for managing and improving legacy systems while maintaining code quality and minimizing disruptions?
I would say the first step is to put an end to legacy if you're working on a legacy system. I'll share with you this experience. I went to a client and they told me they have a 5-year-old legacy application. I went back to the same client 5 years later. Now they said they have a 10-year-old legacy system. And that's what I want to say we want to stop doing. If you have a legacy system, if it's 5 years old, keep it at 5 years old. Don't make it 10 years old. So the very first step I would say is, if you're working on a legacy system, tell yourselves as a team, from today, for any new code we're going to be writing, we're going to bring in better practices. Sure, there are legacy parts in the system, but these are modern parts written really well with good automated test. So find a way to bring good practices into newer code than to simply say, hey, that's all legacy. We're going to keep throwing more code into it. We're never going to be able to make it better. So put an end to legacy. Make sure that any new code being written is done with better quality and automated test. Secondly, I never would ever recommend a team to walk in and start writing tests on legacy code. No, please don't. That is the worst situation to be in. If you force a team to write tests on legacy code, they're not going to be motivated. They're not going to be good at it. They're going to be write really shabby tests and walk away because their goal is to fulfill a mandate than to do quality work. So my recommendation is leave legacy code as legacy. Start writing tests on new code you're writing. When you're about to make a significant change, you're going to modify a piece of code, you're going to refactor it, you're going to add a new feature or fix a bug. Only at the time, genuinely put your effort to start writing tests on that legacy code. One way to do that may have to refactor that code in order for us to write tests around it and then be able to either fix the bug or make the enhancement. This also is good because you are able to devote your effort in writing tests on a much smaller piece of code that you are currently working with from the legacy system rather than going on this mandate to start massively writing tests on legacy code. So my recommendation is write test on newer code and incrementally, but only when you have a need to touch, start really writing test on existing legacy code and don't really mess with it if you have no reason to change it anytime soon. And leave that alone and focus on writing newer code that doesn't turn into legacy code as time goes on.
Yeah, this makes perfect sense. Thank you very much for that. So let's move to our next question regarding artificial intelligence. So with the increasing integration of generative AI and large language models in various fields, there's a growing interest in their potential impact on software development and coding through the use of tools like ChatGPT, GitHub Copilot, etc. From your perspective, how do you see AI transforming the way we approach software development? What are some of the key opportunities and challenges these technologies present for developers, and how can they effectively be harnessed to enhance productivity and code quality?
So I'll make a statement about this in a minute, but I want to set up a context before I make the statement, if you will. So I was giving a talk in one of the user groups, and a lady said, I looked at your presentation just now. With all respect, I can use AI and I can arrive at the same results as you did. Maybe we don't need all this knowledge that you're carrying around. Maybe we can use an AI and do exactly what you did using a tool than needing an expertise like you do. And I looked at her and I said, I'm really glad you said this. And I gave her an analogy that day. And I told her I use Google Maps. And to go around places, I rely on Google Maps. But occasionally, Google Maps tells me to take a turn on a railway track and drive on a railway track. That's when I tell Google Maps, no, I'm not going to listen to you. So I was telling her the expertise is still important because you need to be able to discern between good solutions and bad solutions. Well, she went home that night, fed every topic I discussed in the presentation into AI, sent me a link to it and said, take a look at it. My mind was blown when I looked at it. For one of the problems, it either gave the same answer as I gave, or it was slightly better answer. For one of the problems, the answer it gave is exactly the answer my first year students give. I also moonlight and teach at the university. I often give a problem to my students and I see how they solve the problem. And the code they develop, I often challenge them and they eventually arrive at the right solution. But the code they start with, that's exactly what AI wrote. I kind of smiled at it. Then the third problem I saw, it had a code and I'm looking at it and I'm like, oh my gosh, this code won't even compile. But then below it, the AI is saying, this code is doing this. If you give this input, it'll give this output. It's describing the behavior of the code as if this was a correct code. And honestly, I'm like, am I reading this wrong? Because I know this won't even compile. I just copied the code, put that in the editor, and compilation error. So now I'll make the statement. Is it a useful tool? Absolutely. But in a way, I would say, as of today, AI is like that 3-year-old which occasionally says something really cute, but then spends the rest of the time completely blabbering things that are fictitious, hallucinated, and incorrect. So my recommendation is, should I use AI? Absolutely yes. But use AI for ideas, not for solutions. There's a difference between the two. I'm working on a problem. What are the solutions I should think about? Feed that in AI, and AI says, have you considered A, B, C, D, E, F? Wow, I remember reading about these two. I know about these three. What in the world is these other two? I didn't even know about those. Thanks, AI. You gave me some really nice ideas. What I don't want to use AI is to feed a question, get an answer, boom, put the answer, and walk away. Dangerous. As an example, I was doing a workshop a couple of weeks ago for a team. I called it AI human-driven development. And I gave them problems, and I said, solve this as a human, solve this using AI. And we were learning on techniques, how to leverage AI to give the answers we want. But I gave a problem, and I told the team, for this problem particularly, I have not seen AI ever give a good solution. As a human, you and I can come up with a good solution, but AI doesn't. One of the people in the room said, oh, I have an answer from AI. And I said, really? And she said, it meets your requirements. I am like, wow, I'm impressed then. If you don't mind, can I look at it? So I walked over, looked at her machine, and I'm looking at the solution it created. And in the third step, I said, I would never allow anyone to violate things like that in that line. So the code was doing things that were a complete violation of programming norms that we should be using. This developer was not aware of that because it's a new paradigm for her. Imagine he takes that as a solution and uses it. That can be very dangerous. So your expertise, AI is not a substitution for your expertise. AI is a great assistant. Leverage it for getting ideas, but you are still responsible for the solutions you create. And so you need to be capable of evaluating the ideas and arriving at the solutions that are useful. AI is going to make a huge difference to our productivity in the future, but it's not a substitution for our skill. It's an augmentation for our skill. That is the key for us to keep in mind.
Thank you very much, Venkat. So I've left the best question to last. So your extensive expertise and experience in software development and your contributions to the field are truly inspiring. For aspiring software engineers looking to follow a similar path, what advice would you give them? Are there particular skills, habits, or practices they should focus on to develop their expertise and make a meaningful impact in the software industry, and perhaps become Venkat Subramaniam number 2, 3, 4?
I've got 2 words, only 2 words. Be shameless. That's it. Be shameless. This, to me, is one of the most important characteristics for anybody who aspires to become really good. Newton said, I see the farthest because I'm standing on the shoulders of giants, he said. Every one of us is where we are because we have been standing on shoulders of giants. Ahmed, I'll tell you this honestly. I work with people who walk with pride and they would do things and they wouldn't ask for feedback. They wouldn't ask for somebody to review. They would they would assume what they have done is awesome. And to me, feeling great is one of the best ways to become worst, because that pride really blinds us from how we can improve. One of the things I've benefited from a lot is to surround myself with whom I call as friends who are smarter than me. To be able to walk up to Dave Thomas, the pragmatic programmer, to be able to walk up to Neil Ford or Mark Richards or any one of these other people and say, I've got this idea. I want you to look at it. I've written this chapter. I want you to review this. I've written this code. I want you to critique it. And for them to come back and say how it can be improved is genuinely a very humbling experience, but a very rewarding experience, because I am good, but they help me to get better every day. So my recommendation is be shameless. Don't hold pride that is unnecessary. Instead, go to a colleague and say, hey, I've written this, but I want to ask your opinion. What are your thoughts? If you were to be doing this, what would you do? What would you do different? When you ask for feedback, here's the beauty. You don't have to use it, but you have gotten different perspectives and you can decide which one of them to apply and how to apply it. But in doing so, you're elevating yourselves from where you are to the next level of thinking. So to me, one of my biggest strengths, if I may say, is not that I'm good. No, I'm not. It is because I'm absolutely shameless. I like to go to people and say, critique this for me. Tell me how to improve this. And I'm not going to follow everything you say, but I want to learn from what your thought process is. So my recommendation is mingle with people who have different opinions, different ideas, different perspectives, and be shameless to show what you're doing and get their feedback. That is one of the best ways to elevate yourselves, not only in your career, but in your thinking as well. And that's got a really big impact. So that would be my recommendation. Be shameless.
Venkat, thank you very much for taking the time to be with us today. I have to say this was one of the best episodes we have done. Very insightful and very inspiring. You are an inspiring computer scientist and software engineer and a great gentleman. And we hope to host you again in the near future. Thank you very much.
Thanks so much for having me, Ahmed, and best wishes to you and your listeners as well. Hope to meet you again at another opportunity. Thank you so much again.
Thank you so much.